The topic for this video is histograms and stem and leaf plots. This is two different topics combined to one. So again, this is histograms and stem and leaf plots. We're going to begin by talking about histograms. First, let's define what a histogram is. A histogram is similar to a bar graph and is used to display numerical data that have been organized into equal intervals. Intervals are on the horizontal axis, and the vertical axis are the frequency. And frequency is just how often something occurs. How many times does it happen? All right, we're going to work out a few examples. Now, for these examples, we are going to use the same histogram. This histogram that you see on the left is the one that we're going to be using. So you do need to copy down this histogram here on the left. So go ahead and pause the video and copy down this histogram. All right, this histogram is telling us that the title is The Cars Passing Intersection at Main and 3rd. So it's an intersection somewhere in a town of Main Street and 3rd Street. And it's how many cars are passing it. And here we have our horizontal axis is our time. So this is 12 to 12:15 p.m., 1 to 1:59 p.m., 2 to 2:59 p.m., and 3 to 3:59 p.m., and lastly 4 to 4:59 p.m. And then our vertical axis is a frequency, the number of cars that pass through the intersection during those times. And our question asks us, what interval represents the most number of cars? What interval represents the most number of cars? Well, we're going to look and see. Most would have more cars than all the others. In this case, it's this one here. It has 60 cars. So the interval would be 12 to 12:59 p.m. And that would be the answer. Again, we still have the same histogram of cars passing an intersection at Main and 3rd. Our next question is, how many cars pass through between 2 p.m. and 4:59 p.m.? Well, we're looking from 2 p.m., and 2 p.m. starts right here, all the way to 4:59, which is all the way to here. So I have to look at my 3 different intervals there, figure out how many cars in each one, and add them up. So from 2 to 2:59, we have 20 cars. From 3 to 3:59, we're in between 30 and 40, so that means that it's 35. And from 4 to 4:59, we're at 40. So I'm going to add those up. 20 plus 40, I know, is 60, and 60 plus 35 equals 95 cars. And that's the answer. Our next example says, what percent of the cars passed through between 4 p.m. and 4:59 p.m.? Well, I know that from 4 to 4:59, 40 cars passed. So what we're going to do to solve to find a percent, we're going to set up a proportion. Remember, part over whole. My part is 40 cars. And it's out of my whole. How many cars there were. So here we had 40, 35, 20, this is 45, and then 60. So we need to add all those up. So 60 plus 45 plus 20 plus 35 plus 40 equals 200. And we're wanting to find a percentage. Well, I know that the whole would be 100%. And I don't know the numerator. So we're going to solve this, multiply these ones that are diagonal, 40 times 100, and divide it by what's left over, which is 200. So it would be 20%, and that's the answer. All right, next we're going to move on to stem and leaf plots. A stem and leaf plot. In a stem and leaf plot, the data are organized from least to greatest. Then we have an outlier. And an outlier is an extreme value. It's an extreme value. And you can also think about it as an outsider. Think of outlier as an outsider. It's different than all the rest. It sticks out. Next we have leaf. A leaf is the digits of the least place value. Then we have stem. A stem is the next place value digits. So you have the least place value is the leaf, and then everything else is your stem. Alright, for example, you do not have to draw this down, but the picture on the left is a stem and leaf plot. Here you have the title, it's the survey results. Now, the leaves are over here, and the stem is here. So the leaves are, for the first set, is 1, 6, 8, 9, 9, and the stem in that case would be 0. Now if you take a look down at the bottom, it gives us a key, and the key tells us how to read it. It's telling us that when you have a 2, and then your line separating your stem and leaf, then a 0, that equals 20. So if I were to look at this number right here, 6. In order to read it, I would first look at the number on the stem, which is 0, and then I add my leaf, which is 6. So that number is 6. Whereas if we look at this number here, our stem is a 3, our leaf is an 8, so it's 38. All right, we're going to be working at a few examples, and for these examples, we are going to be using the same stem and leaf plot for all of them. So this stem and leaf plot that is on the left of minutes of TV watching, you need to go ahead and copy down into your notes. It needs to be there. So pause the video and please get down this stem and leaf plot. All right, the first thing that we need to do is find the range of our stem and leaf plot. Remember that range is just the greatest minus the smallest. So we're going to look at our largest number. Remember, it shows it from least to the greatest in our stem and leaf plot. Our largest is 90. And then we're going to subtract our smallest, and our smallest is 45. Go ahead and subtract that. 90 minus 45 equals 45. So our range is 45 minutes because our key tells us it's in minutes. And that's the answer. Next, we need to find the median. And the median is just the middle value. So we're figuring out which number is in the middle. In order to do that, I like to check things off. So I begin with checking off my largest and my smallest at the same time. Then my next largest and next smallest. Again, 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 and again. And we're left with this number here, and that represents 60. So 60 minutes is my median. All right, next we're going to find the mode. Remember that mode is just what happens most frequent. Which one occurs the most? Well, here I have 45 2 times. I have 60 4 times. But I have 75 1, 2, 3, 4, 5 times. So it occurs the most frequent. So 75 minutes is the mode. Next, we're going to talk about the mean. And mean is just the average. And in order to find the average, we add up all of our numbers and then divide by how many we have. So we're going to add all of our numbers. We have 45 plus 45 plus 55 plus 60 plus 60 plus 60 plus 60 plus 75 plus 75 plus 75 plus 75 plus another 75 plus 90. So we're going to add all those up. So put those into your calculator. 45 plus 45 plus 55 plus 60 plus 60 60 plus 60 plus 75 plus 75 plus 75 plus 75 plus 75 plus 90. When you add all those together, you get 850. And we need to divide it by how many numbers we had. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. So our denominator is 13. So 850 divided by 13 tells us that our average is approximately, we're going to round it to nearest whole, 65 minutes. And that would be the answer.